Assalamu alaikum warahmatullahi wabarakatuh. Dear student of first secondary, today we are going to solve trial exam for the previous year. Okay, we have different questions that we needed to discuss. I think you need to study hard before answering these questions. Okay, I hope you understand any point that we are discussing together. Okay, let's start. Question 1 of the trial exam, we have in the following table, we have a table that contains the mass, specific heat and temperature. Okay, I solve like this questions in booklet of الموسوعة. I solve problem like this. Okay, we have here a temperature fixed in all the metals. We have aluminium, copper, iron and gold. Okay, if we have different masses and each one have a different specific heat, okay, let's know what is the question. One of these metals requires a long time to decrease the kinetic energy of its atoms. Okay, we have iron, copper, gold, aluminium. Okay, we have the choices here. What happened to measure the quantity of heat that evolving or present Q of each metal? Okay, at first we didn't have any solution, especially we will make the rule. Okay, at first we haven't any objection here, neglecting the mass as a factor affecting the specific heat. Okay, we said before that the only factors that affecting specific heat kind of substance or kind of matter that we use in in measuring specific heat. So the mass here, different masses not affected on the specific heat. Okay, another point, larger specific heat element. I said before, when element has or matter has a high specific heat, it take a long time to absorb energy and a long time to release energy. Okay, and take a long time to decrease its temperature. So what happened here, or what you can conclude from the numbers in front of you in the table, you see that specific heat, one of them has high specific heat, aluminium. Okay, we said before, okay, it's a note for you, the one that present or the most abundant metal in the earth's crust, it is element, and the most element that we can deal with, aluminium. Okay, this is some information for you. Okay, this means that we take a long time to decrease its kinetic energy of its atom, so the right answer will be aluminium. Okay, we have here two factors that we can mention, that only aluminium is the metal that require that take a long time to decrease its kinetic energy, that we have here what high specific heat, that we gain energy and lose energy taking a long time, or take what take high amount of energy to release energy. One of them take a long time, so the right answer will be aluminium. Okay, let's going to question 2. Okay, question 2 says that we have a 10-gram piece of metal is heated to 80 degrees Celsius and placed in 100 gram at 23 degrees Celsius. Okay, so we have here different metals, we have, or different elements, we have metal, and also we have water. The temperature of water and metal, okay, one of them has high temperature and the other has low temperature, and when mixing both of them, one decrease in temperature and the other increase, and the temperature at the end will be 23.6 degrees Celsius. Which of the following represent the metal? Okay, given that specific heat of water, you know that it is a fixed number, 4.1 84 joule per gram degree Celsius. Okay, we have here iron, its specific heat 0.445 joule per gram degree Celsius, and another one silver Ag 0. Its specific heat 0.236 joule per gram degree Celsius, and also we have number C, copper, its specific heat 0.385 joule per gram degree Celsius, and the last one aluminium that has high specific heat 0.901 joule per gram degree Celsius. Okay, we wanted to know which of them will be the metal that has high temperature that decreases when mixes with water. Okay, at first here we have for metal we have temperature 80 degree, temperature 1, and mass 10 gram, and temperature T2 at the end of the reaction. Okay, we will have two equations or rules that we will use. At first, that we will calculate the amount of heat or quantity that the atoms or that the metal have, Q for metal, and measuring delta T at first. Okay, and in the other part we will measure the Q for water. Okay, so for metal we have, I said, we put the rule. For water we have mass 100 gram, temperature 23, and temperature 23 increases to 23.6. Okay, so we will write the equation. One of them lose energy and the other gain. Okay, so the lose one take a Q for a negative sign, and the gaining one take Q with a positive sign. Okay, we put the equation 2 in each side. We have at first here we have mass Q equal mass time specific heat time delta T for metal. Okay, the other side will have mass time specific heat time delta T for water. So we have here two sides, one for metal and the other for what? For water. So we will make balance for each side for them. We have here, I said we put a negative sign in front of the part that we lose from high temperature to low temperature. Okay, negative in front of this equation. 10 times specific heat time 56.4. The difference in temperature between 80 and 23.6, the difference will be 56.4 degrees Celsius. Okay, on the other side we have 100 and time 4.184 time 0.6. Okay, this is the mass time specific heat time difference in temperature from 23 minus 23.6. So the negative sign here for all the equation not coming from losing Q. Okay, after that we will have here specific heat time this metal 564. On the other side we remove negative in each side, we have 251.04. okay, we will make division for this one divided. Specific heat will be 251 0.4 divided 564. So specific heat will be 0.445 joule per gram degree Celsius. So the right answer will be iron. It is the first metal here in the table. So we have specific heat, but we must solve the rule as we said. We have here iron, its specific heat is the right number. So we are going to question 3. Question 3 says that the data in the following table represent 4 different gases at the same or of the same mass in 4 closed vessels. Okay, the 4 gases were heated at the same temperature. Okay, so the temperature is here fixed and the same amount of mass. So temperature and mass fixed. We have only one factor is changed or different will be what? Specific heat of the matter. We have matter A, it's a specific heat 2.46, matter B, it's a specific heat 1.18, C 2.1, and D 1.35. Okay, which gas acquires smallest quantity of heat? Okay, we said the matter that has low specific heat, that what, that gain or acquire smallest quantity of heat in small amount of time. Okay, so we have here the least one in the, or the smallest one in that gas requires small quantity of heat will be, we have C, D, and B, the end one A. Okay, do you think the right answer will be, neglecting what? We didn't mention that we didn't change the mass as a factor for changing specific heat. Okay, and also smallest specific heat gas take short time to increase its temperature. This means that it absorbs small amount of heat or quantity of heat and lose easily this amount of heat. Okay, so the right answer will be what? Will be letter B. Okay, it is the least one in the specific heat. Okay, let's going to question 4. Question 4 says that the thermochemical equation must have the physical state of the matters due to, okay, why we must have the physical state. Okay, you must understand, I said before in the start of the year that physical state is the most important thing when we write the chemical equation. When we study the ionic equation, I said we must write the physical state. If we don't write the physical state, we can't solve any questions at chemistry. Okay, so the first factor here, difference in heat content due to balance the equation, difference in types of bond, and the first law of thermodynamics. So the thermochemical equation must have the physical state of the matter due to what? Okay, we have here thermochemical equation added with, we have two things that we haven't. We have inside the equation, we have heat content or enthalpy, and coefficient represent number of moles. Okay, before the sample we have numbers, or we call them coefficient, represent the number of moles. So also we have enthalpy or delta H, we write it before the arrow or after the arrow according to the kind or the type of equation, depending on the kind of equation. So we have here depending on what? Depending on delta H or the difference in heat content, or we can say they are enthalpy. Okay, difference in heat content or difference in amount of heat in each one, difference in heat content in each case. We have here 2 delta H or delta H2 minus delta H1. So we have here the enthalpy or different in heat content that we can't write it, or we must write physical state to that help us to know the difference in heat content, that the reaction lose or gain heat, or exo or endothermic reaction. Okay, let's go to question 5. Question 5 says that the thermochemical equation must have physical state of matter due to. Okay, we have some questions here. Question A, choose A. We have 2H2 plus I2, it will give 2HI. And also we have 2H2 plus I2, it gives HI, delta H, here 26 kilojoule per mole. The number C, here we have H2 gas plus Cl2 gas, it will give 2HCl gas, and delta H will be with the negative sign. If we don't write any sign in front of the number, so it will be negative, it will be positive, and here we write negative, so it will be lose energy. So delta H negative 92.5 kilojoule per mole. And the last one D, we have 2H2 plus Cl2 in the case of gases that give 2HCl gas with a negative sign 185 kilojoule per mole. Okay, we must here know the physical state. Why? Okay, we have, if we know that must at equation, at first equation must be balanced. Okay, when we are looking to equation A and B, equation A, here we have 4 atoms or 4 moles of 2 times 2 equal 4. We take 4 moles of hydrogen. Here we have only 2 of hydrogen, and here we have 2 iodine and 2 iodine. That make a difference in the amount of moles that we taking in the equation. So this is unbalanced equation. Equation 2, here we have 2 times 2 4 and 2 iodine, and here we have no each one. So equation 1 and 2 not balanced. Equation 3 or C, here we have 2H and get 2H, 2Cl and get 2Cl. Okay, so it will release energy due to formation of energy, so it is a right. We will complete the last one. 2 times 2 equal 4. Here we have 4, so it will be unbalanced at all. Also D unbalanced, so the right answer will be letter C. Okay, B, question B wrong. Physical state. Physical state, here we have, if we change it from iodine gas and hydrogen gas, so it will make delta H hydrogen iodide in the liquid state, so wrong in the physical state of the product here. So the right answer will be letter C. Why? We said that thermochemical equation must obtain or must contain at all physical state and must be balanced and must contain the heat content with sign of reaction, bond formation or bond breaking. Okay, so it will be what? It will be letter C. Let's going to question 6. Okay, question 6 says that in the following thermochemical equation, here we have H2 plus F2 that give 2HF. All are in the physical state gas. Delta H equal negative 267.4 kilojoule per mole. The coefficient 2 in the product of the equation represent 2 here in the product. Represent what? Represent number A, mole, B, atom, molecule, atom. Here we have gram and mole. Okay, so if we put 2 as a coefficient in front of the molecule of the product, so we have here what we have. It represents the number of moles. We said that we take 1 mole of hydrogen gas and 1 mole of fluorine gas, that product 2 moles of hydrogen fluoride what compound. Okay, so the right answer will be letter D. 1 mole of hydrogen reacts with 1 mole of fluorine, so 2 moles of hydrogen fluoride is formed, so the right answer will be D. Let's go into question 6. Okay, question 7 says that in the reaction 2Hg, that 2Hg, we have here ions, okay, in the case of gas that change to molecule, so we make a bond formation, H2 gas. Okay, delta H here greater than 0 as the reaction is endothermic. Okay, and second one, delta H less than 0 and energy or the reaction is exothermic. Delta H greater than 0 and the reaction will be exothermic. The last one, delta H less than 0 and the reaction is endothermic. Okay, do you think what? We have here 2 atoms only of hydrogen. We want to form 1 molecule of hydrogen gas, so we will need to form a bond. So we will release energy at the end of reaction due to formation of bond. So that the reaction will be, the product will decrease or increase in temperature. The product will increase in temperature, or H2 will has high temperature, so the reaction will be exothermic, and delta H will be with a negative sign, so the reaction will be delta H less than 0. Here we have letter B, delta H less than 0, and the negative amount means, so the reaction will be exothermic. When we want to make a bond, so due to formation of bond, we release energy at the end of reaction, so the reaction is endothermic. Okay, let's discuss. We have 2 points that we want to know or to remember. If we want to form a bond, so the reaction will be exothermic and the delta H will be negative sign. But we want to break a bond, so we need energy from surrounding to the system. So delta H will be at the end of reaction will be in the positive sign, and the temperature decreased at the end of reaction. So when you feel a cooling of any substance surrounding you, so it will be here due to breaking bond, like decomposition or thermal decomposition reaction. It need an energy to activate the reaction. So at the end of reaction, temperature decreases. Like what I said to you, if you take some of cleaning powder and put it on your hand and put 1 drop of water, so we make a solution, you feel hot on your hand due to it is exothermic. It depends on the reaction exothermic that will remove the wastes from clothes. Okay, so it's a kind of element that exothermic at the end of reaction, but we have another different items that will be endothermic, like what? Like photosynthesis. Okay, it is endothermic reaction that needed energy to make the reaction or to make photosynthesis process. Okay, let's going to question 8. Okay, question 8 says that if the heat content of the reactant is 1250 kilojoule and the heat content of the product will be 1720 kilojoule, so we have the product here, the heat content greater than the one in the reactant. So the reaction is exothermic and delta H will be with the positive sign 470 kilojoule. The reaction is endothermic and delta H will be with the negative sign negative 470 kilojoule. The reaction is exothermic and delta H equal negative 470 kilojoule. The last one here, the reaction is endothermic and delta H equal plus 470 kilojoule. Okay, when we discuss if the temperature increases at the end of reaction, the reaction will be exothermic. Okay, so this is the first one, the reaction will be exothermic. Okay, and will lose energy at the end of reaction, so it will take a negative sign or positive sign. No, it will be delta H of the product greater than the delta H of reactant. Here we have delta H of product greater than delta H of reactant, so it will give or it will take energy to make the reaction, so endothermic reaction will be here, endothermic reaction, and delta H will be positive, so the right answer will be letter D. Okay, we must concentrate. One is the product and the other is the reactant. Here we have the product has high energy, and when we make delta H product or summation of H product minus summation of H reactant, so it will be in the positive side, 1720 minus 1250, it will give positive 470 kilojoule, so it will be positive side. If we have the product here delta H greater than the reactant delta H, so the reaction will be endothermic. Okay, and delta H in the positive sign, and we make what? We make decrease in temperature at the end of question 9 says that the attraction forces between water molecules differ from the attraction forces between oxygen molecule due to, okay, this is the first one, polarity and chemical activity. Okay, water molecule differ from the attraction between oxygen. Water has two kinds of bond, one of them hydrogen and the other is oxygen. Okay, it's a covalent bond, but we have here two single covalent bond in water, but in oxygen we have one double covalent bond or dicovalent bond. So here there is a difference in electronegativity or in the polarity. We have here in polar, in water we have polar covalent compound, but in oxygen pure covalent and there is no polarity. So they are different in the polarity and also what, chemical activity and nature, solubility and the polarity and the nature of molecules. Okay, the right answer will be here what, oxygen gas contain, or it may be have pure covalent with no difference in electronegativity. So the difference in electronegativity between atoms forming molecule is equal 0, while water molecule polar covalent compound. So there is big difference or high difference in electronegativity between oxygen and hydrogen. So the right answer will be here D. As I said, polarity is the point that difference between the water molecules and nature of molecules. We have water polar covalent and oxygen pure covalent compound. Okay, pure covalent element or molecule. Okay, let's going to question 10. Question 10 says that the molar enthalpy of H2O molecule exists in energy of electrons and covalent bond. Okay, we wanted to measure the enthalpy of molecule of water, energy of electrons and covalent bond and van der Waals force, covalent bond and hydrogen bond, and the last one we have energy of electrons and hydrogen bond. Okay, if we want to discuss them, we must know heat content is the internal energy depending on the first one, energy between the molecules. We have the van der Waals force and the hydrogen force. This is the first one. In molecule, if we are talking about inside the between molecules, okay, we have here one molecule exists, okay, between molecules, and each one we have van der Waals force and hydrogen bond. The second one, in molecule we have two single covalent bond inside the water. The third point, in atom we have a kinetic and the potential electrons that make a rotation inside the what, inside the atom, okay, or surrounding the nucleus of the atom. So the molar enthalpy of water molecule exists in the first one. Here we have letter A, the first one, energy of electrons and covalent bond. Okay, we have electrons due to rotation. We are talking about the rotation of electrons and kinetic and the potential energy of electrons. And the second point, we talking about what about the kind of bond between the atoms inside one molecule of water. So we mentioned that we have covalent bond and also energy of electron. We are talking about this point. So the right answer, I said, is letter A. Let's going to question 11. Okay, we have question 11. Question 11 says that in the following equations we have two equations. The first one, okay, we have a solid ammonium nitrate with 5 moles of H2O and take a lot of energy, take 25 kilojoule per mole, that changes from solid or make dilution, that giving ammonium nitrate aqueous or solution of it. So the concentration of solid ammonium nitrate will be decreased. The second one, here we have ammonium nitrate also solid, that we adding what, we adding 150 mole of water. Okay, so we increase the number of moles that we taken of water. Okay, we having here 150 moles of water liquid that makes solution or make a dilution by adding water, and taking amount of energy delta H equal plus 23.5 kilojoule per mole. Okay, to make also a solution or aqueous solution of ammonium nitrate. Okay, the question here, which one of the equations will be true? Okay, in the following equation we having here ammonium nitrate here and ammonium nitrate in the other one. Okay, we want which one of the equations will be the true. Okay, equation 1 and equation 2 represent heat of solution. Okay, each one represent heat of solution. Second question, choice B, question 1 and 2 represent heat of dilution. Okay, question choice C, equation 1 represent heat of dilution and equation 2 represent heat of solution. Okay, dilution of the first one. Okay, the last one here, D, equation 1 represent heat of solution, equation 2 represent heat of dilution. Okay, what do you think about which one will be the true? Okay, we want here one of them heat of solution and the other will be heat of dilution. Okay, depending on the amount of water that we taking, if we at the first we take a little amount or small amount of solvent to make a solution, so we said that we make a solution. When we increase the amount of solvent, that we will make the dilution for concentration of what of the solution that we get at the end of reaction. So the first one, equation 1 represent heat of solution and the third one